So I'm going to go ahead and have Mike roll that video. If you could talk us through what we're seeing here in the context of Echodyne's story.
Sure, I'll do my best to keep in sync, but I'll give you here's my nutshell version of the origin story. So Echodyne originated as Metamaterials expertise, patents, and research, and we'll talk about that a little bit more in detail, that turned into a venture-backed company that was really determined to put agile solid-state radar into places where radar had never been practical before due to cost, size, and power requirements. And the video would depict that. We basically have modeled the active electronically scanned array radar that sits in the nose cone of a 5th-gen fighter jet, and have taken that down to a size that fits in the palm of your hand, that's sub 3 pounds. And that's our Echo Guard unit. And we have the Echo Shield unit, which is about the size of a backpack. But the idea is the same. How do we take this gold standard of radar technology and make it practical where it hasn't been before?
Excellent. I know the video is still rolling, but for those that are not savvy in radar, what's kind of the value of radar? In other words, we hear about it, we know it's used, like you said, in not only fighter jets and commercial aircraft for airspace awareness, but what exactly does it do that makes it so important for airspace awareness and protection?
Yeah, so radar is an active sensor. So, we'll talk a lot about drones today, and we see that in the video. I have it up now. Drones are very difficult to detect, really difficult to detect, and the threat is emerging daily, right? I mean, we just saw the attack just this past week, something that was unexpected. So what radar provides is sort of that fundamental sensor that provides an active view of everything that's in the airspace, whether it's a drone that's been built overnight, a new FPV that's been deployed, a swarm of FPVs that have been deployed that are moving faster than expected. A radar will pick that up. It doesn't require a signature or sort of a known signal or footprint to detect that. And so that's where radar becomes this, backbone of a system.
Okay, and I'm going to go with an acronym here just to make sure we're all on the same page. I know ESA is a big deal, electronically scanned array performance. Can you explain what that is?
Sure. So, mechanically scanned array is a radar that spins. You might, sort of the old school. You'll see these depicted in the video that are spinning. Electronically scanned array is actually a beamforming radar that's solid state, that's fixed, it doesn't move. And so beams are formed and scanning the environment as we saw in that video, constantly and at rapid pace, and it quickly identifies anything flying in that environment. One of the cool things about what we do is then we direct other beams towards that object so that we can better verify and confirm exactly what it is and what it's doing, and characterize the behavior of whatever is flying in the field of view.